Hi everyone. So we have Nick here today. Nick is a Udemy instructor, and for those people who do not know Nick, even I didn't know Nick a couple of weeks ago. I saw what would be the best way to go towards WebXR. Okay, again, all these technical topics, Nick is gonna explain about it to you in a simple and awesome way because he's one of the best instructors I have ever seen. And yeah, well, Nick, go ahead. You will be the best person to introduce about yourself.
Hi, I'm Nick Lever. I've done about 10 or 11 courses on Udemy. And in this next hour, we're going to have a look at how to create WebXR apps using 3GS. 3GS is a great open source WebGL library, and it makes bringing 3D to the browser about as easy as it can be, which, it's challenging for some people, but nevertheless, 3GS makes it as easy as possible. Do you want me to carry on, or shall I crack on?
Yes, let's go for a demo, folks. Yeah, everyone is excited. We've got 10 plus viewers right now, 15 viewers right now. Great. So give a like for Nick and share it with your friends as well. And cool. So let's crack on. So whatever Nick is now wearing is Oculus Quest, and it's one of the Quest 2. Wow. Okay, cool. Oculus Quest 2. It is one of the awesome VR devices from Facebook. And you want to see how Nick sees inside his VR? I can show you that one as well. So Nick, whenever you are ready to share your screen, also we can share it and show the world what you see.
Not quite ready. Be there in a minute.
Definitely.
Oh, it says my headset's already casting in another window, which I can't see.
Yeah, just go ahead and share your screen. I may be able to help you.
We'll be there in a minute.
Sure. And folks, if you have any questions related to WebXR or anything related to that, feel free to drop in your comments. So WebXR is one of the new technologies that is happening right now in the web world. It is a mixture of virtual reality, augmented reality together. It's called as extended reality. And the native support for WebXR is already available most of the time in your browser, most probably. So we could easily find out those classes that are available in the console.
Okay.
Is it ready? Okay, cool, great.
How do I share my screen now?
There should be a Zoom window where you can press share screen like how you did before.
Yeah. Sorry, I'm new to this sort of thing. Okay, you should be seeing it.
Can everyone confirm whether you are all able to see the screen nicely? So that's exactly what Nick sees in his VR headset. So yeah, Nick is going to explain the rest.
Okay. In the next hour, we're going to look at creating this app. Very simple. As I move my controller around, I'm casting a ray at the various balls on the screen, and they're highlighting. So we're going to look at that, how that's done. And we're also going to look at one of the common problems of VR is moving about a huge environment. This is an architectural walkthrough, and we'll be moving around it. Hope you can see what you probably can't see it facing away now. But we're going to have a look
Wow.
at how this is created.
So when you put on the headset, this is exactly what you would be seeing in both the eyes.
That's right. If I stand up, it's kind of obvious that I'm moving up. And we can go up the stairs here. Have a look in various rooms. Okay, that gives an idea of what you can do, and it's all in the browser without any plugins.
Exactly. You don't need anything else. Just your browser and some JavaScript is all you require.
Okay, I can take my headset off now.
So the way these 3D things work is there are like, 6 direct degrees of freedom or 3 degrees of freedom. Should we explain about the degrees of freedom right now?
Yeah, we could do. I've got a PowerPoint that I'm going to start.
Cool, go for it.
Okay, I guess we can see that.
It looks awesome. Go on.
So the absolute basics of WebXR. WebXR is an API that was created. It currently is only supported on Android and Chrome desktops. So it's currently being developed by Apple for Safari and Safari Mobile, but it's not available on iOS yet. So it's Android and desktops, Mac, Linux, you name it. Whenever you're dealing with a WebXR app, it must be being delivered by HTTPS. You must be on a secure browser. You can't be HTTP. That's an absolutely crucial thing. If you try to do HTTP, it won't work. And for WebXR to exist, you've got to search for XR in the navigator object. So as long as XR exists in the navigator object, there's going to be some WebXR capabilities on the browser that you're currently playing with. Before you can start an immersive experience, you can't do it automatically. It's a little bit like trying to play sound. You can't directly play sound in the browser. You've got to have some user interaction to start the sound. It's exactly the same with WebXR. There's got to be some user interaction. So you usually provide a button. And if you're going to do VR, because bear in mind WebXR supports AR as well as VR, and AR is something that you'd use more regularly on a mobile device. But if you're going to support VR headsets, like the crazy thing I've just been wearing, then you must be, the device itself must support immersive VR. There is actually like a repo for this. Probably easier for you to download it after I've finished this stream and maybe play the stream back. I'm assuming this is recorded.
Yeah, it will be available in YouTube later as well.
Yeah, so
link.
That'd be the way to do it. Just type away the things I'm going to be explaining after you've downloaded the repo.
I'll do that.
Okay. I'll stop there and we'll move to some code. 3.4. I'm on the wrong one. Okay. So if you download the repo, this is what you're going to see. And if we go in the start
Nick,
one.
Do you mind if you can zoom in a bit using Command plus?
The type is going to be a lot bigger.
Okay, sure.
Type's going to be a lot bigger. So if we look at, that's quite visible, is it?
Wow, that's cool. Okay, it's perfect.
Okay. 3GS is available from the 3GS library. But if you download this repo, there's already the main 3GS file is the one called 3.modules.js. If you know anything about 3GS at all, then you'll know it comes in three formats. It comes in module-based, TypeScript-based, and basic JavaScript-based. If you want to use the WebXR support in 3GS, then you're going to have to use the module one. So that file there, which we're doing as an import, is directly from the 3GS version 128. It's in the build folder. This VR button is something that's adapted by me from the VR button that exists in, let me see if I can remember this. I think it's in the examples JSM WebXR folder in the 3GS repo. But for mine, it's just in the libs folder. So you'll see the libs folder here, various things from 3GS, and a couple of files that are added to it. And this is one of the additional files. Probably the most sophisticated part of the 3GS support is this absolutely amazing class file, the XR controller model factory. Whatever version of headset that you're currently using, the XR controller model factory will provide a model that looks just like your controller, and it'll do it automatically. There's a little bit of code you've got to write, but precious little considering what it's doing. So,
Nick, is it possible for us to use the same 3JS in React?
Yes, it is. But don't ask me for the React way of doing things.
Yeah, I'll figure it out. A lot of people are from React background as well, so I thought.
Yeah, you definitely can. You can do WebXR using is it React 3 Fiber, and that approach. Although the main file from the three libraries, 3module.js, there is lots of additional bits and pieces that 3GS provides in the examples folder, and box line geometry is one of them. We'll look at that in a minute. And stats, which we don't use in this, and orbit controls. Orbit controls allows you to rotate around outside of a WebXR experience. Okay. Anybody who's familiar with 3GS will be very familiar with this. It's very boilerplate stuff. We create a camera, and it's a perspective camera. That means it's got a field of view, an aspect ratio, a near and a far. When you're dealing with any form of real-time 3D, you have a frustum. And a frustum, it has an aspect ratio, and it has how near you can get to the camera and still show polygons, and how far away from the camera you can get and still show polygons. But we won't worry too much about that. So you create a camera. By default, all WebXR VR cameras are at 0, 1.60. This one's just set a little bit further back in the Z-axis by setting Z to 3. So with 3 back in the Z-axis, it's a little bit further away from them balls before we enter the VR experience. We're seeing it as a wide view of it. We create a scene, set a background color to just a gray color, add a hemisphere light. A hemisphere light has it has no position or direction, but it has a different color pointing up and pointing down. So it's a bit like you've got two colors pointing in on each other. And normally what you do is you set the one that's pointing up to be much darker than the one pointing down to give a feeling of the sun. We also have a directional light and a renderer. and we create a controls object, which is orbit controls. Orbit controls allows you to rotate around, nothing to do with WebXR, just allows you to rotate around with the mouse. We create a raycaster, a working matrix. If you know anything about 3D, you'll know it uses matrices all the time. Don't over worry that if you don't know about it.
There are a lot of people in the who are attending the live stream. They are good with 3JS, and there is Srinivas Prabhu, who has been working with 3JS since 2013. Who all are actually working with 3JS? Your experience, please put a small hi and tell about your experience as well. Cool.
Great. So then we call the init scene, and then we call setup XR. Let's have a look at the init scene first. We're setting up a small radius. So the radius is, everything in WebXR is in meters. So 1 unit in WebXR is 1 meter. So here we're saying that the balls that we're creating have a radius of 8 centimeters. We create the room, so that's the grey room with the lines you saw in the first version that we looked at, with just the balls in the room. We're moving out the geometry. Well, the way that 3D works is you have a combination of geometry and material. Geometry is the individual points and the way they're connected into triangles. And the material is the color and the way that that's rendered. It could include a texture being applied to it. And the scene we created it originally, everything that we are ultimately going to see on screen must be added to that scene. So all that's happening here is we're creating a simple room with the grid of white lines. And then we're creating some geometry, which these are the balls. So icosahedron geometry, and an icosahedron is the basis of this, but then we subdivide it, and then we have a radius, so that's the radius of 8 centimeters we just talked about. And then we subdivide that twice. So each triangle in your icosahedron is subdivided twice. So from a single triangle to 4 triangles, and from 4 triangles to 16 triangles. And by doing that, you're getting a smoother, much more spherical basis for the geometry itself. And then we randomly position 200 of these in this for loop. We also create a highlight object. The material we use for the highlight object is just white. And we set the side for it to backside. That means instead of the front face of the ball showing, we only see the back face of the ball. By default, if we didn't put that, it would be front side. And then we set the scale of it to be a little bigger than the original one. So when we reposition our highlight, it's going to be at the original ball, but it's slightly bigger than the ball. And because it's showing the back face of it, it's like putting a cup behind the ball. And because it's mesh basic material, it won't be using any lighting at all. It'll just be a white outline. So that's how you're getting the white outline, just by having a ball that's slightly bigger than the original ball and set to backward facing polygons. Okay, now we get into real WebXR area. In order to show anything that's WebXR, we need to set our renderer, the renderer we created in the constructor for this app. We need to set the renderer XR property. everything to do with WebXR in the 3GS library is going to be found in the renderer XR property. And we need to set enable to true. Forget to do that, you'll be at it all day and you'll see nothing. So very, very important point. And then we're creating a button, which is the VR button. That does a lot of work. The VR button does an awful lot of work. We'll have a quick glance at it. As I say, in this library, it's extremely similar to the one that comes by default in 3GS, but in this instance, I've just adapted it slightly to add some additional features and make it so it's got the headset icon on top of it. But essentially, it's the same thing. So notice what happens in the constructor is we first find out whether or not XR exists in the navigator. Remember, we talked about that at the very beginning. We find out whether or not it supports the session we've currently got. Everything in XR, most things in XR are promises. So it's the basis of promise, then do something else. So in this instance,
even if they are going to be based out of promises, we could use await and async as well, right?
Say that again.
Async and await are supported in terms of WebXR as well. In case if we want to do some synchronous.
If you wanted to do AR, you'd be looking for immersive AR. If you want to do the session mode that you're looking for, can be immersive VR, immersive AR, or inline. Generally speaking, it's immersive VR or immersive AR. Inline just means we're just showing things in the browser as though it's just not an immersive experience.
Got it. And there are two related questions. Should we take it up right now?
Yeah, go ahead.
So Aman Chopra is asking, is 3JS very popular like React? I mean to ask if there is any scope of 3JS in the industry, as I have started learning with React.js only.
3JS has just entered its 11th year.
Wow.
And it's by far and away the most popular of all the WebGL libraries. Millions and millions of people use it. Very, very well supported. Terrific community base. 1,700 developers have contributed to the open source library. Huge project started by Riccardo Capello, and he's still supporting it. It goes through about maybe 4 or 5 versions. No, probably more than that. Probably more like 10 versions a year. So getting on for a new version every month. Very well supported. Very up to date. You can be quite confident that if you're developing with 3GS, it'll still be there in 5 years' time.
And there is one more question.
And for people coming at it from a React point of view, there is an entire subgroup of 3GS called, I think it's called React 3 Fiber, R3F, yeah. And that's essentially 3GS. It's 3GS under the hood. The rest of it is just, the XML base of React on top of it, just to make it simpler to code. It uses the React version uses the TypeScript version of 3GS, but you can be 100% confident, definitely. There's also Babylon JS, which is supported by Microsoft. That's not 3GS, but that's one of the competitors. Play Canvas, quite different, but again, doing essentially the same thing. AR Frame, which is A-Frame, which is built on top of 3GS. So they're the big ones. So coming back to this, before you can run before you can run any... Sorry.
There was one more related question here. So Srinivas Prabhu is asking, like, I wanted to ask Nick, what's a good way to do collision of controller grip and objects in a VR scene? Is using colliders the only way? That's it.
We'll come to controllers shortly. So we'll come back to that when we're looking at controllers. We're talking about controllers, and we'll come to that. We haven't yet started an immersive experience. So once we've got into an immersive experience, we'll be able to talk about controllers. So now we know we've got a Navigator XR object. We must look to see whether or not the session mode we want is supported. If it is, we're going to get a flag here that's true or false. If it is supported, then this bit of code just shows a relevant button. And if it's not supported, then this bit of code shows that you can't use WebXR on the device you're currently looking at. These are just various things that happen if you're not using HTTPS or you've got no WebXR in the you've not got an XR object in the navigator. So if we're showing the VR button, then we've got to this stage with various different options for session started and session ended. So it's actually doing quite a bit of work, the VR button. Depending on your application, you'll probably want to rewrite it, because an awful lot of the work that's going on here is also styling the button. And you'd probably want to overwrite that and restyle the button in the way that you want your button styled. But the important thing is you've checked whether XR's available in the navigator, you've checked whether the session mode you want is available, and you're making sure that a button press starts any immersive experience. That's the most important and critical part. Miss any one of those key components out, and you won't be able to see a WebXR VR experience at all. Okay, so coming back to our app. So we've created a VR button on screen. We passed the renderer to it so it can do a bit of querying. And now we're up to our controllers. Okay, controllers in WebXR are a bit confusing. I've got what we've got is we've got two different coordinate spaces. We've got the ray space, and that's the controller itself, and that starts from the end of your controller and points directly out like that. And we've got the grip space, which tends to have the model centered, so the key point, so the origin of it is at the middle of the model, and it aligns differently to the target ray space. But that shows the actual controller model itself. So it's split into the controller target ray space and the grip space. Okay, bear that in mind. Okay, so when we create the controllers in this particular thing, we're creating this wonderful XR controller model factory. Superb bit of code. I think it's Brandon Jones, I think he wrote the code for it. He's one of the key people writing the WebXR API. We create a bit of geometry, which is just going to be the line we're casting out, the ray we're casting out. So that's just going to be a ray, which is just a single line in white. Then we create an array of controllers. There's only going to be two, left and right. This is the key thing. Renderer XR, remember everything we get is from the XR object of the renderer. Get controller, that's going to be 0 or 1. Get controller 0, left 1. Get controller 1, right 1. and then we add our line to the controller. You don't have to do that, but if you're going to be showing which way the target ray is pointing, then the line's a really useful way of doing it. So we're adding the line that we created in this bit. We're adding it as a child of the controller object. And everything in 3GS, every object in 3GS, this is going to be a 3GS object by this point. Every object in 3GS has a user data custom object, and you can put whatever you want in the user data. In this instance, I've just put select pressed equal false. So we've not got there are two key buttons that have got very easily accessible events on them. There's the select button, which is on the Oculus, that's the one. That's that one at the end. And there's a squeeze button, which is the one on the side. There. So select button and a squeeze button. So I'm just putting select pressed is false. And then I'm adding this controller to our scene object. And then I'm pushing it into our controllers array. Remember I said there's a separate one for the grip. So the actual model that we see, all we're doing with this controller is we've just got effectively just a matrices, just a matrix that describes its position in the world space of the WebXR experience. That's it. That's all there is to it. We're adding a line to it, so a child of it is going to be this line pointing out, but it's not a model. So the controller itself isn't a model. It's just the target ray. For the grip, we use get controller grip, again pressing 0 or 1, and then we add an actual model. And that little line of code there, that sweet bit of code there, will get the object from a database of objects based on the device you're currently using. So it'll be different on a Quest 1 or a Quest 2 or a any of the headsets. There's about 20 supported. The Go, Oculus Go would get a different one. Rift would get a different one. They all get different ones. So depending on which one you got, you'll get a different model appear in your scene that looks exactly like your controller just by using that one bit of code. How sweet is that? In order to see it, obviously we've got to add it to our scene, but that's all you need to do. And it will move, everything about it will move as the hand moves around, and the controller will show its line. But the actual model of the actual 3D model of your controller object is this bit of code here. Okay. What happens in the render loop? I'm assuming you know a little bit about 3D here, because if I've got to teach you 3D, I'll be here forever. In the render loop, what happens on a real-time 3D application is we have a constant render loop. So the browser is constantly being refreshed, but ideally 60 times a second. And generally speaking, we do it in a method that we call render. And in this instance, for each of the controllers, that's the left one and the right one, we're calling handle controller. And then once we've got everything in the position it needs to be, then we call render and render the scene based on the camera's position. Now the camera's position is completely and utterly controlled by your head. So once you're in an immersive experience, you don't need to worry about repositioning anything. the camera will take its coordination from wherever your head is. If you, this comes back to the 6 degrees of freedom question. An Oculus Go is 3 degrees of freedom. It only supports orientation, so it only supports the direction in which your head is pointing. But a Quest or a Rift are 6 degrees of freedom, so they know whether you've moved or not, and as well as the direction they're pointing in. But you don't need to do anything about it. That will all be handled behind the scenes by the headset and the code being applied to it. All you need to do is make sure that you've followed all the rules about HTTPS, checking what session mode you've got, whether you've got XR in the navigator, and starting a session.
Nick, quick question from Moriko. Why is this code block wrapped in a for loop for the remote grip part?
Say that one more time.
Why is the code block where the remote or grip part is there is wrapped in a for loop?
There's 2 grips, one for your left hand and one for your right hand.
Okay, thanks.
Yeah,
that was actually explained by another person. Thanks, Harshvardhan.
Yeah, two. So you need one for each side. And another sweet thing about this wonderful bit of code that I'm really excited about is that it caches the object. So if it knows you've already downloaded a version of the grip, then there'll be a cache version. It won't be going back to the asset store to get the 3D model. It'll already have it available to it. Okay, that takes us back to here. So we've built our controllers. There's now going to be on select start. On select our controller, each one of our controllers has, actually I've got a thing for this. Play from this slide. Okay. The controller has a limited number of events. A controller is actually more flexible than just these events, but we won't cover the gamepad side of things. It supports a select start event, a select end event, a squeeze start event, and a squeeze end event. Those are the 4 events you can easily handle. So coming back to, so here this is going to be a function that is applied when select start occurs, and this is a function that's going to be applied when select end occurs. All we're doing is, in this instance, this is going to be the controller itself. We added a line to the controller. Oops. And the line is going to be child number 0, index 0. And we set the scale in the Z, that's directly along, to 10. So now the line is 10 meters long. If in WebXR, remember, a single unit is a meter, virtual meter. And remember, we had a user data property, which was select press, set originally to false. We set it to true. Once we get to select end, so the button's been released, we set the scale property for the first child to 0, so it's now a length 0. We set the highlight object to false, it's no longer showing. And we set the select pressed user data for this controller to false. So we apply these events, select start and select end, to the controller on the left and the controller on the right. Remember that we've got 2 controllers. Okay, so that takes us to the handle controller method. Here we've got the controller pass to it. Just remind ourselves that this came from the render method. So this is going to be called anything up to 60 times a second. And it finds out whether or not user data select pressed is pressed. If it's not, we can ignore it. I mean, there's nothing to do. We're setting the scale Z property to 10. We don't really need to do that, but it's just kind of there. Now, we created two working properties of this class in the constructor, a working matrix and a working vector. That's just because it takes a little bit of time to create a new instance of any of these things. And so it's quicker to take an already existing one. Identity, you know anything about matrices, identity is going to turn it into a matrix that does nothing. It's just got ones along the key diagonal. Then we extract the rotation from the controller's matrix world. So now that matrix will be just a matrix that would rotate something that is the same as the controller's target ray. That's what it's going to be doing. And then we create a raycaster. A raycaster is a useful 3GS property, 3GS class that we can create, where we can project something in a particular direction from a particular point and find out whether or not it hits a variety of different objects. Really useful bit of code for collision testing. And here we're setting its position to the position of our matrix world, so where our controller is based. And we're setting the direction of the negative Z-axis to the same direction as the controller. So we now have a ray that's pointing along our target ray. So our raycaster ray starts from the controller and goes along in the direction that the controller target ray is. If you use the grip space, this wouldn't work. It'd be completely the different direction. You've got to use the controller target ray space. And then we find a bunch of intersects, so that we take out the children in our room, that's the balls, and find out whether or not the ray we've just created hits any of them. If it does, then they're going to be ordered with the nearest one. This is going to return an array. And if the length of the array is greater than 0, we've got a hit. And the order of the array is it starts with the first object is the nearest. And so that's the one we're going to be adding the highlight to. So we get intersects 0, that's the first one in our array. We add our highlight object to it, turn the highlight object to true, and scale our ray so it doesn't go through it. We scale it to the intersect distance. So the ray that we're casting from the controller now stops at the ball. And if the intersect's length is 0, then we don't have a highlight, that we're not highlighting any balls. So we set the highlight visible to false. That's all the code you need to do that first example. And now we'll move on to moving around the college. When you're dealing with, oh no, don't want to play from the start. Sorry about that. Play from the current slide. When you're dealing with the VR camera, you can't set its position. You can't set its position and you can't set its orientation. So how do you move it around a VR world when you're limited to your own 2-meter room? And you might be moving around a room that is 100 meters square. The way you do it is you put your camera, that's your virtual reality camera, you put it on a dolly. A dolly is just simply an object 3D that's got no mesh. It's just a matrix that has a position and an orientation. So what we're doing with the college one is we've added we come back to this, close that one down, open this one. We've now got a dolly object in our scene. We've added our camera, that's the virtual camera, we've added it to the dolly. So if we move the dolly, then our camera itself moves. So that's the trick. The trick in dealing with it. Sometimes people don't want to move smoothly. They want to go to teleport. You'd still use a dolly. To teleport around, you'd still use a dolly. You'd move from one to position to another, rather than just little small increments of position changes. So all the code we're going to look at on this one, essentially it's the same thing as the other one. We create controllers, we create grips. The only real change is the object we loaded is now this college object, and the camera itself is attached to a dolly. The way we're going to constrain this dolly to the environment we're in is we're going to use a proxy object. Now, if we look at, this is in Blender. Blender's a 3D application program. We can't quite, how can I move that? Can't, got it. The red is a simplified version of the college called a proxy. And the purpose of it is to define where the dolly is allowed to go. So coming back to, so if you look at, whoops. So you can see that it's just tricky to see, but the red version is a really simplified version of the 3D environment, just enough to allow us to constrain our dolly. Back to this. Okay, so what we're doing we check, when we loaded our object, we found the object that was called, that had a name that included proxy. I mean, you could use any name you want, but in this instance, we found the one that we'd called proxy in Blender. And once we found it, we set a property of this application called proxy to that. So if we didn't find it, there'd be no point in carrying on with this move dolly. And then we have how close we're allowed to get to a wall. We're saying we can't be any closer than 1.3 meters. This is a speed that we're going to be moving along. And we clone the dolly's position and then move up in the Y by 1 meter. The Y in WebXR is up and down. X is left and right, and Z is in and out. And essentially what we're doing, again, setting a raycaster to cast directly down from where the dolly position is. And by it should, all it's trying to do is intersect with the proxy object. This allows us to go up and down stairs because it's going to find a point. Because the reason we've moved ourselves up in the Y and then cast down is it allows us to find a point that's a bit higher.
So any movements like this in most of the games, is it through dollies, nothing else? Is
Yes. Yes.
And Nick, we have got one question. It's good to do raycaster dot intersect objects, object comma recursive true, if you have deep descendants that you want in the results as well. Okay. So it's like extending to my previous question. Raycasting is one option, but I want
Raycaster's got two methods for intersecting objects. It's got intersect object, which deals with a single child, yeah, and it's got intersect objects with an S on the end, and that will intersect with an array of them. And quite rightly, there is a recursive as well. So if you put true here, then it will recurse through any child descendants of this particular object. I think that's what the question is. Didn't sound like a question. It sounded more like somebody who knows what he's talking about. More like
a statement. Yeah, sorry about that. I guess I got confused. Yeah, it's a statement.
Yeah. But it's a good point. Yeah. If you want to, if the object you're dealing with has got loads of descendants, and it's important that you're including them in the intersection code, then you'd put recursive true. But essentially, what you're doing with this particular function is we're dealing with a test down, and that's going to define the height of the dolly as it moves along. Then we're going to test forwards. So we've now tested down, and we've moved, assuming that it's not blocked and we can move. Then we test forwards, assuming we're moving forwards. And if the array we're dealing with hits a wall, then that would block our movement forwards. So we're testing down, we're testing forwards, and we're testing left, and we're testing right. And by those 4 different tests, we're constraining the movement of our dolly to be within that proxy. Another way of doing it is to deal with navigation objects, navigation meshes, but that's for another time. And if you want to check it out, it's in the game version. So I'll just forget that. Let me show you. There's a load of examples. All of these are available at nixgames.com WebXR. And the way that this one moves.
Nick, is it okay for you to share this with all of them who are not a part of your course as well?
Yeah, it's fine. Yeah, it's fine.
And obviously, if you want to learn how these things are done, please go and buy Nick's courses.
I'm going to come to that. A great way of testing things when you're developing, it's quite tricky. Just keep looking at your headset version of things. But a great way of doing it is to install the WebXR emulator for Chrome, and that will allow you to, if I start an experience, it'll allow you to move around And the movement in this example all uses a navigation mesh. Different way of dealing with things. Okay. So you preempted me about my sales pitch. For the next 4 days, my WebXR course is at best price by following this link. bit.ly WebXR-live. And my GLSL course, that's for shaders. If anybody who's fancying doing some shaders, is GLSL-live. Or you can go on the Udemy site, search for WebXR or GLSL, and use the coupon code May21_live, all caps. And you can go to nicklever.com courses for lots of other courses on 3GS, all at discount prices. I've got a Facebook group specifically for 3GS, which is bit.ly Nick 3GS. YouTube channel, which is bit.ly Nick YouTube. And my Twitter is @NickLever. And you can get all these links directly at nicklever.com. That's me done.
Wow, that was awesome.
There's a lot to take in.
Yeah. I'm like, okay, so what am I doing right now? Like, what exactly is happening right now? That's my current thought at the moment.
Are we still live?
We are still live. We are still live.
Are there any more questions to deal with?
Let me quickly find the questions. So, oh, wait, actually, I haven't transitioned it yet. Okay, got it. Yes, we are live. Yes. Hey, folks, do you still have any more questions? We have got a really nice number of questions, nice list of questions from Srinivas and others. So Srinivas has another question. A simplified version of the question would be, how would I grab objects in the scene using a controller, single raycaster, ray physics, colliders, or multiple rays from the controller? That is the question.
I wouldn't use physics. A good example of doing it is in that version I've just shown you of that game. So I'd have a look at that. I think it's 8.3 in the WebEx in nixgames.com WebXR. You can download the entire GitHub thing. If you just search for Nick Lever on GitHub, you'll find it. And you'll find that one of the things you can do is open the treasure chest. And the way it's opening the treasure chest is by using a controller. So what we're doing is we're raycasting the controller till it collides with a point on a mesh. And then we're trying to keep the point on the mesh and the intersecting ray in the same place. That's what we're aiming at doing. Might not be able to keep it at the same length, but wherever possible, we're trying to keep it in the same point. There's quite a bit of, it's one of those things where you need to know a little bit about matrix multiplication and that sort of thing. It's a slightly tricky thing to do, but a good starting point, as an example, would be that, where we're opening the chest. I'd have a great look at that, because that's where I would start.
Awesome.
Physics is a different point. There's another example again in the same repo that uses physics to move a box on screen. what we're doing there is we're dealing with constraints. Again, it's another way of dealing with it, to deal with constraints and physics. But controlling the movement of something with physics is always challenging. So if you can avoid using physics and just use a constraint that doesn't use a physics library, you'll probably find things easier.
Got it. Thanks, Nick. And there is another question. It is about testing, related to testing, question on testing. Can we test every scenarios using the Chrome emulator, especially for those without any devices?
As a developer, you're going to really struggle if you haven't got a headset. The WebXR emulator is great. In fact, it's brilliant. And it'll take you an awful long way. But at some stage, you're just going to have to test it in a real headset. So it's going to be really challenging if you haven't got it. And if you've only got Google Cardboard, then you've not got any controllers, and so it's very limited what you can create. So definitely the first place to start is debugging in the emulator. But once you've got something that is essentially working, it's going to be really, really tricky to avoid seeing it in a real headset, because moving your controllers and moving your head is a totally different experience in the emulator, and very difficult to judge where an intersecting ray is being targeted. So yeah, you can go a long way, but at some stage you're going to have to borrow a headset off somebody.
Thank you so much, Nick. Nick, I guess we are running out of questions, and we are also running out of time.
Great.
So it was really it was an enlightening session for most of them, especially from I guess a lot of your students have also joined, I believe, right?
Good. I don't know who we've had.
We had a couple. I mean, we had a lot of people here. So Srinivas Prabhu, then Harshvardhan Gomez, Bhavesh. I guess he's my friend, I believe. We got a lot of people, a lot of new faces. Thanks everyone for coming in today. And yeah, I hope it was really a new experience. I mean, it was completely new experience for me. Now I personally would like. Yeah, right. It's your first live stream, right?
Yeah.
How was it? You made an awesome, really awesome.
Good. It's always so difficult to know the level to hit it at, because if you go absolute beginners, because the course I'm currently developing is for absolute beginners, then what I just said would have gone way over the head. But if somebody's got a little bit of knowledge about matrices and is interested in the WebXR API, then 3GS is a brilliant way to go. Absolutely brilliant way to go. Couldn't recommend it highly enough.
Awesome. Same thing. I couldn't recommend highly enough about your courses, and you've been like super inspiration for me, and I believe a lot others as well. And thanks a lot for accepting my invite to come and do something awesome here. Thank you,
problem.
Nick. And let's say a quick bye to everyone. Nick, please stay here, and
Okay.
we'll just have a quick talk, and then we will leave. Yeah. See you all then.